Good morning, students. Welcome to our next class. So, in the previous class, we have discussed about the introduction, that is, the definitions of artificial intelligence, the various angles in which we are going to define what do you mean by an artificial intelligence. So, in today's session, we'll be looking into the problems of AI, or we can call it as the domain of AI. Now, there are a lot of areas in which the artificial intelligence can be applied. So initially, now you can see that earlier the works started with the game playing. So that means when we consider the older, or the in the year 1950s, so initially they started applying the concept of artificial intelligence for games. So later on they extended that to the theorem proving also. So that means small theorems in the field of mathematics, now it was been applied. So now later on, now another important area in AI is started focusing was on common sense reasoning. Now, like say when we are talking about common sense reasoning, so it includes the reasoning about the physical objects and their relationship to each other, now as well as reasoning about the actions and the other consequences. So they started with game playing, then theorem proving, then they started extending their work in the common sense reasoning also. Now initially when we are talking of game playing, now there was been like say Newell, Shaw and Simon, they built a program called a general problem solver, or GPS, now which they applied to several common sense tasks, as well as the problem of performing symbolic manipulation on logical expressions. So when you have got a very small applications, or we say a certain theorem proving, now they started to apply this general problem solver, and also to some of the common sense reasoning problems also. Now if you consider the various domains or the task of our AI, now it can be gradually, it can be classified into three different types of tasks. The first task is called as the mundane task, that means day to day task. So we can try to understand here that, now here, like say perception. So one of the areas in which AI started working was in perception, that means like say vision and speech. So when we are talking about vision, so our digital image processing comes into the picture. So how we can try to recognize certain objects. So similarly the speech recognition, that is with respect to the voice, now how we are able to recognize the speech, that also comes into the picture. So then natural language processing. So natural language processing is another very difficult, very complicated area, because here now we are supposed to understand the language. So not just the commands or the English, that are handwritten language, but the natural language. As you know that the natural language is very complicated. Like say for example, when we are talking about our English itself in India, you know that when we are having the English, so lot of what we can say, the mother tongue influence will be there. So there will be lot of mother tongue influence when we are using the English language itself. So when we are talking about natural language processing, now you can see that, so the various small different tasks comes into the picture when you are talking about natural language processing. Like say understanding, it can be generation. So like you have to first understand the language, so then generation of the language, translation of the language. Now all these are the some of the areas in when we are talking about natural language. Similarly, the common sense reasoning was another task, and the robot controlling, if you are going to build a machine and how we are going to control that particular machines. Now all these all these examples can be grouped under the mundane task. So the second different type of application here is called as a formal task. So now especially when you're talking about the formal task, the game and mathematics comes into the picture. So games, like say as we told that initially we started the AI with respect to the games, like chess we have got. So a lot of programs, intelligent programs has been built, as we have already discussed, as seen in our previous class, that Deep Blue was a machine. It's a machine, so which is a very fastest chess playing machine in the world right now. Apart from that, you might be downloading some small chess program from the internet and we try to play. Now all these type of small programs have got their own intelligence built in that particular algorithms, so that the system is going to play. Basically, when you're talking about the games, the researchers are going to concentrate on 2 by 2 game. That means 2 by 2 games means one side a user is going to play and the other side the computer is going to play. Similarly, we have got backgammon and checkers and go. No, these are the some of the examples. Of course, there are so many games are there, but we have considered here. So game is one type of sub area under the formal task. Similarly, the mathematics. So now in mathematics also, like say whether it is geometry, logic, or calculus, integral calculus, so theorem proving, now all these are the various areas of mathematics where the AI is being applied. Now the third task is our expert task. It is called as the expert task. We have lot of expert systems. So like say in our course, now in our last module, now we will be taking some examples of expert task, or we can say expert systems, we call it as, because it is an already very built programs, especially for certain particular domain. When you're considering expert task, we have got the engineering. So when we consider in the engineering domain, whether it is designing the circuits or designing the machines or designing the layouts, whether it is in architecture or any other hardware, fault finding, if there is any problem in our circuits, now the programs itself can identify the faults. Manufacturing planning, so like this the various areas comes under when we are talking about the engineering. Similarly, we have got scientific analysis can be done, medical diagnosis. This is one of the very important area where right now the artificial intelligence and we can say the machine learning is being applied. So medical diagnosis, because by using the AI and by using the machine learning, really we can help lot of patients, and diagnosis can be up to a particular level, or more accuracy can we can obtain by using these machines. And similarly, financial analysis. Now these are the three different types of tasks now what we are actually having. So I think these are the different domains. So sometimes in the exam you will be getting a short note, so explain the different domains or the task of artificial intelligence. Then you have to explain all these things. You have to start with the mundane task, then the formal task, then the expert task. So with the so till now, what we have studied or what we have tried to understand is what is AI, the definition of the AI, the four angles in which we are looking about the artificial intelligence, and the areas or the domain in which AI is working. So next level, so now we are going to consider one simple game, that is tic-tac-toe, and try to design the algorithms for that. So starting with a normal way or by applying our brute force method, so how we try to design an algorithm to solve that particular problem, and then later on we go into the improvised algorithm. Now before going into the algorithm, now we have to understand so few important definitions, or we can say certain important things we are supposed to define or try to understand before we take up that particular examples, right? So now we'll see what are those important uh, uh, areas, or we can say the important questions which we are going to uh, consider. So now these are the following important few important questions are to be considered before we go into the next level. So what is the first question? So what is our first question? Now what are the underlying assumptions about the intelligence? Now when we want to build an intelligent system, now we should have some assumptions. So what should be our intelligence, right? So how we are going to define the intelligence? Like say for example, for our human beings, now we try to define AI. Now we say that what is the intelligent quotient or IQ of a human being. As we know that as our age increases, the IQ also level decreases. Right now we want to build an intelligent machine or intelligent program. So first thing, what is the assumption we are making about intelligence? According to the machine or this particular program what you are going to build, what is the assumption you are making about the intelligence? That's the first thing which we are going to discuss. And the second thing is that what kind of techniques will be useful for solving AI problems, right? What type of techniques we have to use? Are we going to use the normal techniques, or whether we have got a different type of techniques? Because Generally, when we are talking about solving problem using applying AI, now we need to use some kind of techniques. So that's what we'll be discussing. What kind of techniques will be useful for solving AI the problems? And the third question is that the level of human intelligence can be modeled. What level, to what level of human intelligence we have to model? See, what we are trying to do here, we are going to model one particular program or a machine and call it as an AI machine. Means now this particular program is going to work in a better manner than the human being. Right now, human being who is performing that particular task in a very good manner, now more than him, this particular model with the system has to be modeled. So in that case, what should be the level of human intelligence can be modeled? So we have to think, like say for example, now when you are writing some of the games, say for example you take the chess. Now when you want to play the chess games in our systems, now we have got different levels, like say starting level, intermediate level, or expert level. This is what it said, to what level you want the human intelligence to be modeled into your AI program. This is the third question which you are also supposed to consider. And the fourth one is, when will you come to know that an intelligent program has been built? So when you are going to come to know, okay, this is where I have to stop our particular program and I have created a intelligent machine, so I can stop this at this particular moment of time. So these are the four important points which you are supposed to consider. Right now we are going to start with the what is called as underlying assumptions. Right. So we have to understand now what is actually the underlying assumption. Right. So this is the first point, as we have seen. So what was the first point? What is the underlying assumption? So now, so before we are going to assume or define the assumption for AI, now we have to define the some another important definition, so which is called a physical symbol system hypothesis. So we are going to define one hypothesis which is called as a physical symbol system hypothesis. Now this is the heart of any AI researchers, and it was been defined by Newell and Simon in the year 1976. Now they called physical symbol system hypothesis. Now this physical symbol system hypothesis, or this particular definition, consists of four important points here. The first one, now it has got symbol, expression, symbol structure, and system. Right. So we are going to define this physical symbol system hypothesis. Now you can see here how this they have defined the physical symbol system hypothesis. So a physical symbol system, right? So you can see here, a physical symbol system consists of set of entities called symbols, right? So it consists of some set of entities called symbols. So which are physically, or which are the physical pattern that can occur as component of another type of entity called expressions, or it's also called as symbol structure. So what it means that a physical symbol system, when you consider a physical symbol system, it consists of some set of entities called symbols. A lot of entities will be there, like say for example, now if you are going to consider as we have seen in our class, say if you take an expression and say a is equal to b plus c, now you are going to consider one expression in any programming language. Now when we try to look into this, so when we convert this high level language, that is this syntax of high level language, into low level or assembly level, how does the computer is going to process this entire statement? What it does, it divides it into tokens. So in assembly level language, we call that each one is divided into a token. Now a is a token, equal to is a token, b is a token, right? Now each one, now in general, now here, now you can assume that any physical symbol system you consider, now it consists of some set of symbols, now which are the physical pattern that occurs as component of another type of entity called as expression. Now if you consider this each as a token, as a, when you group all these token, then only you get an expression, right? So without grouping that, you are not going to get an expression. Or another simple you can understand is that you take our English language. Now we have got 26 alphabets are there. Now each alphabet we can call it as a symbol. Now when you group these alphabets properly, then you are going to get a word, right? You are going to get a meaningful word when you group that particular alphabet. Similarly, in any problem when you are going to consider, if when we are telling a physical symbol system, it consists of set of entities called symbols, which are physical patterns that can occur as component of another type of entity called an expression or a symbol structure. Clear? So next, now a symbol structure is composed of number of instances, or what we call tokens. Now when you consider this structure, symbol structure, now it is composed of number of instances. Like instances means what? So when you know in our object oriented, when you define a class, you have got object is an instance of a class, right? There might be so many instances. So a symbol structure is composed of number of instances of symbols. Now it has got various instances of symbols which are related in some physical way. Like we can say that this is one expression, or I can say that A is equal to B divided by C. This is another expression, right? This is another instance. Only thing, what the symbol has been changed. So now a symbol structure is composed of number of instances of symbols related in some physical way. Clear? So now at any instance of time, the system will contains, now when you consider in general at any instance of time, now a system contains a collection of these symbol structure. There will be collection of various symbol structures, and the system also contains a collection of processes that operates on expressions to produce other expressions, right? It is very it's very understood that, because now when you have got various symbol structures, now the system, it contains a certain process. There should be certain process which operates on this to create another type of expression. So you are going to get an output. So process of creation, modification, reproduction and destruction, now all these things will be there when we are discussing any physical symbol system. Now this is how they defined a physical symbol system. Now once that has been defined, now we are going to define what is called as a hypothesis. What is the underlying hypothesis for artificial intelligence? Now what does this hypothesis says? Now observe carefully. A physical symbol system, that's what we have defined earlier, has the necessary and sufficient means for general intelligent action. Now when you consider any general intelligent action, that means you are going to use, like you want to build a model or a system which is going to use some form of general intelligence, then the physical symbol system has all the necessary and sufficient means, because it has the symbol. These symbols are being grouped into expressions, and we have got various instances, right? So when you consider a physical symbol system, it has all the necessary and sufficient means for any general intelligent action. Now this was the underlying hypothesis what has been defined. So now why this, now what we are going to tell is that now computers, that is the machines what we are going to use right now for building this AI or the machine learning, now computers provides the perfect medium for doing all this experimentation. Our system gives us a perfect medium for this experimentation, since they can be programmed. So we can program this machine to simulate the physical symbol system we like. What type of physical symbol system we want, we can try to program that, we can try to simulate that, because the computer system supports, it has got lot of features. So why we are using the computers, all of us know. So the importance of physical symbol system hypothesis, what we say, it is of twofold. Now it is a significant theory of nature of human intelligence, and so is for great interest to psychologists. That means we can try to, with the help of these computer machines, now we can try to build an intelligent machine, right? Now this is the first point, that what we have studied or what we have understood, the underlying assumption of our intelligence. The next is, what is an AI technique? So what is an AI technique? So now artificial intelligence researchers during last 3 decades from the 1950 when they started, many people started about discussing about the AI intelligence, how to impose the intelligence into the machines or into the program, and we are going to call it as artificial intelligence. Now they concluded that one important thing, intelligence requires knowledge. This is very important for us. So if you want to build an intelligent machine, now we are saying that it should require the knowledge. So without knowledge, right, so we cannot call it as an intelligent machine. So intelligence needs the knowledge. Now when we come to know that knowledge is very important, now there are certain few important characteristics, or we can say properties, which this knowledge possesses. So of course in our second module we will be going in detail about the knowledge and all. Right now, to understand the what is an AI technique, now we are going to understand this. Now what are these properties of our knowledge? Knowledge is huge, it is very huge, as you know that. So knowledge is not a small, so it is very huge. Like say for example, now today, since you have already learned C programming language, now can you say that you are expert in C? No. Why? Because the sea itself is such a big ocean. The knowledge required is very big. You take for example not only the computer's programming language, or you take on, you try to take on any what is that programming language. So you, or any subjects, you say, so whether it is on medical field or any other field, you, when you take any subject, is it any human being, can he become expert in that particular subject? No. Why? Because the knowledge which is required in entire your lifetime, if you read also, the knowledge is very huge. That is the entire world, the environment, or whatever you see, the knowledge is very huge, right? So the first important property what the knowledge possesses is that it is very huge, right? So once you know that the knowledge is very huge, okay, so once you know that knowledge is very huge, now let us see what is our second important property. The second important property says that now it is difficult to characterize correctly, right? So when the knowledge is very huge, now can you properly say that or characterize it correctly? Again, it is very difficult, because you think that you know something about C programming language, but you don't know completely. Why you don't know completely? Why you are not an expert in that? Because it is very huge. Now since it is very huge, you cannot read or try to have acquire the entire knowledge, correct? So now once you don't have the complete control over the knowledge, or you don't know the knowledge itself, then it is very difficult to characterize correctly also. This is the second important point. And the third one, it is constantly varying. Now this is also very important. So it is not that the knowledge is not a static, so it keeps on changing, right? Now today, every day we are learning new things, right students? So every day as a human being, now we are learning new things. It might be in our academics, it might be the general concepts surrounding us. Every day we human beings, every day we keep on learning till our life ends. So now when you are learning, the knowledge keeps on varying. It is not we can say constant. It constantly it varies, it keeps on changing. See, 10 years back what was the technology, today it is different, isn't it? Like say, or you take for example our human beings ourselves, is that when we were small kids, for any small particular disease, what was the medicines which were prescribed? Now the medicines which were prescribed for small kids, it does not apply for larger, or we can say that for elder people, because when you are elder, you have grown, so obviously there is some changes. Similarly, when you are talking about the knowledge also, it is constantly varying. That is another property. And the fourth one is it differs from the data by being organized in a way that corresponds to its application. Now, what does this point say? That no, don't get confused or saying that knowledge and data is the same. In our initial classes itself, we have seen what is the difference between a data and the knowledge. Now obviously the knowledge, it differs from the data which has been organized. If you simply keep some data and organize it in proper fashion, you cannot call it as the knowledge. And the last point is, it is very complicated. It should be complicated. Why it is complicated? Because it is huge. Knowledge is very huge. Difficulty, it is very difficult for us to pinpoint and say correctly, yes, this is what. No, because we don't have complete idea or complete uh, control over the knowledge, because it is very huge, it changes constantly, right? Because of that we can say now this knowledge is very complicated. Now these are the some of the important points or the properties which knowledge possesses. Understanding that this is such a complicated thing, now we need to define this. So because if you want to build an intelligent machine, you should have the knowledge sufficiently, right? So now we'll come here. Now what do you mean by AI technique? Now AI technique is a method that exploits the knowledge. It is going to exploit that particular knowledge which has certain properties which you have seen right now. So it exploits the knowledge that should be represented in such a way that, so we are going to represent, we have to exploit the knowledge, and knowledge should be represented in following ways. Now what are the ways in which the knowledge should be represented? The first one is the knowledge captures generalization, right? So it captures the generalization. When you are going to represent a knowledge, always it should be in general form. So you should not say that this particular knowledge is only for A or B. No, it should be more general. It should be, the knowledge captures generalization that shares properties are grouped together rather than being allowed separate representation. So instead of having separate, now you try to group all the similarities and try to make as general as possible. So for example, now if with your all your knowledge and everything, now if you try to make one particular drug for one disease, now you cannot tell that okay, this drug we can give only for Indians, it is not for Americans. Or any drug we cannot say that it is only for Americans, it cannot be given for Indians. When you manufacture or when you try to implement or get one particular drug for a disease, so irrespective of the region, now that particular drug should be applied, right? Or say for example, now if you are going to write one program, now what we say generally, so the program should be as general as possible. It is not that the program should be limited to only this particular machine or only for this particular example. No, it should be general, that n number of times you can try to run that particular program. And this is what it says, the first point. So in AI technique is a method that exploits the knowledge that should be represented first generally. The knowledge should capture generalization. So don't try to separate representation, you don't make. If it is similarities are there, try to group it. Second one is, it can be understood by people who must provide it. So whoever are going to provide this knowledge, now it should be understood by the people. Even though for many program bulk of data comes automatically from reading. Now there might be so many data, bulk of knowledges which are coming, because knowledge keeps on changing constantly. Now what we say that when you are representing knowledge, now you have to represent in such a way that it should be understood by the people. Now when you are going to represent a knowledge of a particular domain, right? Now if you are not able to understand, then there is no mean. So what we say, the knowledge should be as general as possible, the first point. The second point is, it should be simple. In another word we can say, it should be the knowledge representation should be as simple that not only the person who is going to provide it, he should understand, also other people should also understand that particular thing. So that's what we try to say here. And the third point is, now in many AI domains, how the people understand, the same people must supply the knowledge to the program. That is what it says, that depending upon the domains, right? So when you are going to get the knowledge, so obviously, so you should get from a specified, or you can say expert domain. So how the people are going to understand, and the same people has to provide the knowledge also to the program. So this point is trying to tell us that, So expert domain information or knowledge is required for us. So today you want to build one particular AI machine for a medical diagnosis or anything. So then you have to collect the knowledge from the domain expert, right? So you cannot collect the knowledge from someone else. So the domain expert, he should, from him you are supposed to collect the knowledge and give to the program. Clear? The next point is it can be easily modified to correct the errors and reflect changes in the real condition. Now, as we know that one important property of the knowledge, it is changing constantly. Since the knowledge is changing constantly, your program should be written in such a way that it can be easily be modified to correct the errors. If errors are there, you should be able to correct the errors, right? And if there is any changes, so then it should adopt to that particular changes, take that changes and try to overcome that particular changes into its particular program. So that means you have to represent the knowledge. Representation should be such a way that it should be easy to change. Like say for example, when we are going to define any softwares, when you are going to implement any software, generally what we say that okay, today you have written a software, now after 1 year if the customers are demanding something else, then your software should be written or designed in such a way that small changes, it should be easy for the customers to handle it. Now if you say that one small change, if the customer is telling you, tell that okay, I cannot do this software cannot do, we cannot change this software, again you should go and build a new software, means again time and money, everything are been wasted. So what we say, changes it has to be done. So okay, modification should be easy for us. The next is it can be widely used even if it is incomplete or inaccurate. So even though the knowledge is incomplete, because it is very huge, we cannot have the complete knowledge, still if the knowledge is incomplete or inaccurate, you should be able to use that. That is what the representation should be. And the next is it can be used to help overcome its own bulk of sheer bulk by helping it to narrow the range of possibilities, right? So what it says that now the representation of the knowledge should be in such a way that it should overcome its own bulk of knowledge which is coming. See, and every day when we say that knowledge is keeps on constantly increasing, when the knowledge keeps on increasing, so now we have to take care that the changes whatever is coming, the changes whatever is happening, so now your representation should be in such a way that it has to overcome that bulk, huge bulk amount of knowledge which is coming, right? This is what it is going to tell. See, in our lifetime, say for example, we learn so much of things, students, right? So much of subjects, so much of general knowledge surrounding us. See, our brain is in a position to handle all things? No. What our brain is doing, which is required, we store it. Which is not required, gradually we keep on erasing. The brain is not in a position that it cannot keep. Say for example, does any of us knows who was our friend in LKG? One or two we might be knowing, because now the our LKG students, when we are growing being a friends from the LKG, then gradually if we are growing and if we are friends till college level, then you remember. But other students, when you studied in LKG, there were more number of students. Do you remember everybody now? We don't remember. Why? Because the brain doesn't need that. So gradually when more knowledges are coming, obviously one by one, which is not required, now the brain tries to remove it from that particular knowledge is removed from the brain, right? This is how it has to be, otherwise you cannot keep everything. Like in our normal programming language, when you are going to talk about, so we use garbage collectors, right? So in Java and all, built-in garbage collectors are there. Now why the garbage collector is required? Because to release the memory. So if you don't release the memories, the memories which is been taken by variables, constants or other parts of our program, obviously the memory consumption will be more, the efficiency will be reduced. So what the garbage collector does, whichever is not used for more period of time, gradually it releases automatically, so that user need not take care. This is what this particular point is going to say. So these are the important points. Now what, now we have discussed under the AI technique. So this is what, when we are telling that this is an AI technique, now these are the very important points. What is AI techniques and what researchers came to know? They came to know that okay, knowledge is very important for intelligence to build, and knowledge has got certain important properties, right? Now this is in today's this particular session. Now we have seen up to these particular points. So in the next topic, right, now what we are going to consider, now we are going to start with one particular program, that is tic-tac-toe. So we consider a tic-tac-toe problem, and we will try to build the programs. Now how we are going to work with that tic-tac-toe, so that will be taking up in our next session, right? So thank you for listening to this particular session. Now try to understand the concept carefully. So now based on these concepts, so we'll see by taking a simple example of a tic-tac-toe game, and we'll try to understand now, starting from initial level to little bit of knowledge, and how we are going to provide the intelligence to our particular games, right? So thank you for listening to this video. Have a nice day. Bye bye.